if we release the press load and we can lift the cooling module, and you can see it's a little bit swaying because we hope that when the press load is exerted between the process of the cooling and heating modules contact, the two surfaces can be adjusted a bit to make sure the contact is uniform. And from this photo, you will also see there are 3 points fixing the cooling module. And for this part, please don't move it. The main purpose of these 3 points is to make sure that the cooling module, when it's pressed down, can be positioned to the center part. If we move these 3 points, actually that will affect the coaxial condition of the cooling and the heating module. If you want to know more about how to operate this TEAM tester, we'll have other videos to demonstrate. The following will be the measurement of thermal impedance and thermal conductivity. In this part, we're going to introduce these functions through our software pages. There are main 5 categories for different samples. First is the total thermal resistance of thermal paste or thermal grease. Because for the performance rating of thermal grease and thermal pad, thermal resistance is an important factor. The second mode is the measurement of thermal conductivity, basically for the thermal pad. So we need to have 3 different thicknesses of the same sample, and we know the correlation between thermal impedance and the thickness, and then we can calculate the thermal conductivity. The third mode, is the measurement of pad deflection. Here we are talking about the soft and soft thermal pad. At different press load, they will have different thickness. So we can find the correlation of thickness and press load, and we calculate its deflection rate. The fourth mode is the thermal conductivity test for thermal grease. The main difference between the fourth mode and the second mode is the type of material, because thermal grease is a liquid, so we need to measure it along with the fixtures with different thickness. And the mode 5 is the measurement of thermal conductivity for the MCPCB board. And for this item, we need to notice most of the MCPCB cannot have 3 thicknesses available. So we can only have 1 thickness. So, and other materials with negligible deformation, we can also choose mode 5 to measure its thermal conductivity. Now we are looking at the first test mode. It's the total thermal impedance for grease or pad. And you can test the different press load and temperature for one sample. And there are 2 modes. First is the step mode. If you want to test the press load from 20 psi to 80 psi, and in step every 20 psi, you can choose step mode. And on the lower part is the indicating mode, which means that each condition can be set different temperature and press load, and also the duration, the time. So in this print screen, you can see there are 4 conditions with different press load from 20, 40, 60 to 80. Usually, we'll set different press load and temperature, so we'll know the thermal impedance value at different press load for one thermal grease. And also you can know the thermal impedance at different temperature for one phase change material. The second test mode is thermal conductivity of thermal pad. In this case, we need to have one sample with 3 different thicknesses, and we'll get the correlation between thermal impedance and press load. And the software will calculate the linear correlation and its slope and then the thermal conductivity. As to the MCPCB board, because it's a composite material, it's not easy to prepare 3 thicknesses at the same time. So we measure its thermal resistance and thermal conductivity with one single thickness. The main purpose of this TIM tester is to measure thermal impedance. So we can also get the thermal impedance and calculate the thermal conductivity. Originally, in the previous description, we acquire thermal conductivity and contact resistance from 3 different thicknesses. But if we can know the contact resistance at first, then the total impedance minus contact resistance, we can get the material's resistance. And if we know the thermal impedance or resistance of the material, and we know the thickness of material, we can get its thermal conductivity. So in this case, if the thickness is constant, we can get the thermal conductivity without having 3 thicknesses. And here we are going to describe further about the test method for the hot solid material. So here you can see the schematic drawing. The up and the lower part are contact surfaces, and both are applied the thermal grease, and there are 2 contact resistance. And in the middle is the sample, which is solid and with negligible deformation. So the first step, we need to measure the thermal impedance. And the second, we measure the total impedance, including the impedance from the grease and impedance from the MCPCB, the sample. And we get the total thermal impedance and minus the thermal impedance of the thermal grease, we can get the thermal impedance of MCPCB. We can assume that we know the source of impedance from the MCPCB, including 3 layers. First is from the aluminum, second from the copper, and the third from the insulation layer. So in this case, we can also minus the thermal impedance of copper and aluminum, and we'll know the thermal impedance of the insulation layer. Once we know the thermal impedance and thickness of insulation layer, we can use the formula thickness divided by thermal impedance, and we know the thermal conductivity. Let's move on to the test page for MCPCB. So right here, you can see the highlight on the bottom of this page. So you can key in the thickness of the board and the thickness of the insulated material or the insulation layer. And the third, you can type in the contact resistance from the thermal grease. And the fourth, that will be the thermal impedance from the metal layers, could be aluminum or copper. After we key in all these factors,